Okay, we've determined that the axis of symmetry for this graph has to lie at the negative b over 2a point of the quadratic function, and that is the point where x equals negative 5/2. We've already determined that there are two other ways to construct this graph, but we're going to stick with what we get from the quadratic formula because it's kind of handy. Okay, now we want to find the coordinates of the vertex of this parabola because a quadratic function does give us a parabolic graph. So we want to locate the vertex. Is it down below the x-axis like this? Is it above the x-axis like this? Is it way up here? Does the parabola open downward and have a vertex below the x-axis or above the x-axis? Well, we can easily calculate the vertex because we've just found its x-coordinate. How do you get the coordinates of a point if you know their x-coordinate? You plug that x-coordinate back into the function. That gives you the y-coordinate. So the vertex is on the axis of symmetry. So the y-coordinate of the vertex is found by plugging x equals negative 5/2, which is the x-coordinate at the axis of symmetry, into our equation y equals x squared plus 5x plus 9. We do that, well, right there are the details. We get 11/4. So we just plug negative 5/2 into this function, and we get y equals 11/4, meaning the point negative 5/2, 11/4 is the vertex. So here we have the graph. Here's x equals negative 5/2, the axis of symmetry. Here's the vertex, and its coordinates are as advertised. Okay. Now that's not drawn very well to scale. You can do much better, but that's the way the graph will appear. So we could take the y equals x squared graph and transform it by moving it 5/2 of a unit to the left and 11/4 of a unit up, because the y equals x squared graph has vertex at 0, 0. To get the vertex to this point, you're going to have to move from 0, 0 to negative 5/2, 0, and then up to get to negative 5/2, 11/4. Quadratic functions do choke me up. Excuse me. Okay. Okay, well, that's pretty much it, although we want to do it again with a better scale. I don't have this thing up quite high enough relative to how far it is over. Should be up about here maybe. Okay, so again, this picture summarizes the vertex is on the axis of symmetry, which we found plugged from the quadratic formula. We find the axis of symmetry, and then we plug that negative 5/2, the x-coordinate of our axis of symmetry, in to the function, and we find the y-coordinate of our vertex. Then there's the question for a quadratic function with a parabolic graph. Does it have a maximum or a minimum? Okay, well, any parabola that opens either upward or downward is going to have either a maximum or a minimum at its vertex, right? In this case, the minimum value of the function occurs at the vertex, and the minimum value is 11/4. If the parabola opened downward, then the vertex would be the maximum point, the point at which y has its maximum value. Okay, the maximum or minimum y value occurs at the vertex. It's the y value at the vertex, the maximum or minimum value of the function. And that's a very handy thing. We'll see that in a number of applications.